To get us started, let's talk about the reason behind the GuniMix Pro. Blue Water Pools currently uses the 634 mix elevator for the building of gunite pools. In the nearly 20 years of using these systems, they have observed multiple issues that have made their machine more difficult to use. With the goal of designing a new and improved trailer to use for their core business, they brought their idea to GVSU Engineering. The most pressing issue with this system was consistency. The valves on the existing system are not very accurate, making it difficult to fine-tune the sand-to-cement ratio without wasting significant time and material. There was also no way to monitor the machine's output ratio other than visual inspection of the spray. The unitless dial for a rich or lean blend gave no numerical way to ensure repeatability. Visuals were also used to track sand and cement levels in the hoppers. Wear resistance of the augers, namely the feed auger, was also a big problem. The feed auger required replacement after less than 2 years. In order to extend the life of the auger, a weld bead was placed along the blade as a repair, but this was not a very effective solution. The sponsor also wanted to reduce the number of required operators for the system. Previously, the system needed upwards of 8 people to function, and the sponsor wanted to get this down to 3 people. Also, material is frequently lost during shoots in windy conditions when the gunite blend falls from the feed auger to the C10 rotary gun. This design features the following improvements to the existing system: increasing control of the sand-to-cement ratio and auger speeds, improved monitoring of hopper levels, auger speeds, and material output, improved auger life, upsized hydraulic system for more efficient heat transfer, rubber chute to enable material breakup, reduced number of required operators, reduced material loss from feed auger to C10 rotary gun, sufficient power to accommodate future auxiliary hopper system. Let's talk about how we did it. The beam placement on the frame of the trailer was done in accordance with the desired weight distribution of 60% in the front of the trailer and 40% in the rear. A compensating hitch was selected to remove some of the tongue weight. This shifted the weight distribution, allowing the single axle design to be maintained without pushing the axle too far forward to be maneuverable. The main chute features a rubber trough to allow operators to break up hardened material in the chute, allowing for easier maintenance. Additionally, the rubber chute is adjustable, making it possible to modify the offset from the auger as the blades wear. The auger material was also upgraded from AR225 to AR400, which approximately doubles its wear resistance. As a result, the life of the auger was extended significantly, reducing the frequency of replacement. The sand and cement hopper geometries were maintained from the previous system, but the auger shaft sizes were standardized so that the same bearings could be used for both hoppers. The same type of bearings as the feed auger were used for the sand and cement augers. AR400 was also used to improve wear resistance, although this was not a major issue for these components. The engine was upgraded from 31 horsepower to 60 horsepower because the previous one was not appropriately sized, causing Blue Water to redline theirs. Keeping the hydraulics cooled was something the previous trailer struggled with, so the hydraulic reservoir was upsized to allow fluid to cool in the reservoir before cycling back through the lines. Additionally, the heat exchanger was upgraded to one with a higher rate of heat transfer. The speeds of the auger motors are controlled by pressure-compensating solenoid flow control valves. This type of valve accounts for upstream and downstream pressure changes to maintain steady fluid flow and thus motor speed. On-off functionality is controlled by directional control valves located in the lower portion of the operator control unit. To upgrade the pneumatic system, a high-flow water separator was added to the system. This removes water from the line before sending the air downstream. Its maximum flow rate of 742 cubic feet per minute at 100 pounds per square inch, permits the C10 rotary gun to operate at maximum capacity. Addition of an automatic drain air filter removes particulates from the air to protect particularly sensitive components. This specific model removes particles as small as 5 microns. 3 quick disconnect ports were added for the use of air tools to clean the trailer. Pneumatic lines also power the motor that propels the system's water pump and the vortex cooler, which prevents overheating of the PLC enclosure. Because some job sites use well water as their source, a pump was needed to boost pressure up to around 55 pounds per square inch. A diverting valve is used to control whether the water goes to the pump first for a boost, or if it goes straight to the heat exchanger to cool the hydraulic fluid. Additionally, flat fan spray nozzles are positioned along the lid of the main auger to help reduce static electricity in the event that the sand entering the system is overly dry. One of the more critical changes for this trailer was the addition of a PLC. This allows the operator to control all parts of the system from one user interface. The speed of the augers can be changed with the HMI mounted on the door of the enclosure. Inductive sensors are used to monitor auger RPMs, providing the operator with accurate readings and calculations of the current mix ratio. A radar sensor positioned at the top of the sand hopper tracks the height of the sand, so an audio-visual alert can signal to the operators when levels are getting low. While working on the GuniMix Pro, the team faced some challenges. File management was a struggle for this project. The final assembly has upwards of 2,500 components and over 800 unique part files. Students had to teach themselves how to make weldments, sheet metal components, and chain patterns. They taught themselves these skills by watching videos and looking at SolidWorks pages. Learning these new methodologies included learning how to make specialized drawings. This project was very fabrication heavy. So many team members with little fabrication experience needed to gain a lot. People learned how to mill, bend, weld, and effectively prep raw steel for finishing operations. Along with learning how to fabricate, the entire team had to critically think about how to move large components and sub-assemblies safely and efficiently. Most of the team had never had to rig anything before, so that was a new experience for all of us. This was a challenging but exciting project for everyone involved. All on the team learned a lot and gained valuable skills to use in their careers. Again, thank you to Blue Water Pools for giving us the opportunity to work on such an expansive project. And thank you for the support of our faculty advisors at Grand Valley.